In this video, I'll be explaining 40 LINQ functions in .NET, which allow you to efficiently query and transform the data in your applications, enhancing both performance and code readability. Hey guys, and welcome to Zool Coding. The LINQ functions in this tutorial are available in both C# and VB.NET console or desktop apps. I'll be writing them in C# today, but the code is available in both languages from the link in the description. We can use LINQ functions on any enumerable type like a list or an array, allowing us to query the data or manipulate it in some way without having to use for loops and if statements. We can use LINQ functions with the query syntax here, which looks like an SQL query, or you can use the method syntax, which just involves chaining functions like this. Each syntax achieves the same results. For this tutorial, I'm going to be using the method syntax to keep things a bit simpler. So let's dive in and look at filters and projections first. I've created a person class here, and we'll make use of this throughout the tutorial, and it's just a simple class that contains a name, age, and email field. And when we output it to the console, it'll show up in this format. Above, I've declared an array of people, and I made some helper functions for outputting things to the console. Let's take a look at our first function, where, which is a simple way to filter out items in a dataset. If we want to get people over 30, we can do that like so, passing in a lambda function, with the x parameter being the item we want to check. So this is essentially looping through the array and only returning the items that match this condition. We can also try the same thing for the name field, but notice that this will always return a new enumerable collection, or list of items, so if we wanted just one item, we can add on the first function like this. However, this can return an error if there are no items, so a good idea is to use first or default, which returns the specified default value if there are no items. And conversely, we can do the same but for the last item in the collection, with last and last or default. The next function is of type, and it's a way to only retrieve items that match a specific type. In this case, we've got an array of objects, and we're only returning the string items. Another common function is select, allowing us to project one collection to another one. Let's say we want to get the list of names or ages in our people array. We can do this by returning the value we want in the lambda function. I've now got a list of strings and I want to return an array containing all the individual words in the collection. I could use the select function again, but this returns a collection of string arrays. To flatten this into a simple one-level array, we can use select many like so. If this was a list of objects instead of a list of strings, I get an error on the split function because this is only a function for strings, not all objects. We can use cast in this case to cast all items of the collection to a string beforehand. There are also some functions in the enumerable class, such as repeat, which can duplicate multiple values into an array. If we wanted to output a separator line in the console, we could create a collection of hyphens like so, and then join them all up. We can do a similar thing for numbers. If we wanted to create a continuous set of numbers, for example 1 to 10, we can use a range function, and let's use a where function we saw earlier to restrict this to only even numbers. We'll move on now and look at how to sort, group and join data. So let's start by sorting our collection of people by age, and we can simply do that using the order by function. And the order by descendant function sorts a collection in the opposite direction. We can also use a first function on the end of this to get the youngest person in the array. If we wanted to do a secondary sort in case two values are the same and we couldn't decide which should come first, we can add on a then by function. If we were sorting by the length of the name, we could do a secondary sort on the age. Similar to before, we can use then by descendant to sort the other way. And a bonus function I'll add in here is reverse, which simply reverses a collection. We can also create groupings based on the data we have. Let's say we want to group the people by the top level domain of their email address, for example .com, .net, etc. We can get the top level domain like so, and pass it into the group by function, which creates an enumerable collection of groupings. We'll loop through this like so, and then output the key, which is the top level domain, and the group itself. As you can see, the people are now grouped correctly. Another database-like operation is joins, and we can do that as well using the join function, which allows us to join two collections together by a certain field. I created a new list of pets this time, and I've also added in a new pet class down below, which contains a name field and a person representing the pet's owner. To perform a join on the people array and the pets array, we first specify the first collection, people, then call join, and then specify the second collection, pets. The next two parameters let the function know what's common between the two arrays. In this case, the entire person object is common with the owner property in the pet class. The last parameter then allows us to return a new combined object, combining the information from the pet and person classes. We'll just return a dynamic object with the person name and pet name. And in the console, we have the list of groupings. But this list contains duplicates if one owner has multiple pets. For example, Alice appears twice because she's the owner of Coco and Bella. So to avoid this, we can use the group join function instead, making some small adjustments as we'll now be returning a comma-separated list of pet names per person. And we now have one entry per person and a list of pet names each. Let's see how we can use quantifiers and partitioning next. We can check if all items in a collection satisfy a certain condition using the all function. If we wanted to check if all people were over a certain age, we can do that by specifying the condition. And if all items meet the condition, this will return true. Another similar function is any, and this returns true if any one of the items match the condition. If we wanted to see how many items in the collection satisfy the condition, we can use the count function here instead, which returns an integer value like this. Let's move on to the sequence equal function, which returns true if a collection matches another one. This doesn't check if the collections are the same by reference, but simply compares all the items in the sequence to see if they match. Just to demonstrate, I've created a new collection with the where function and compared it with the original array. This tells us that all people are over 18 because the collections are identical, but not all people are over 50. Let's cover the next set of functions that skip through items in the collection. I've created an array of numbers using the range function we saw earlier, and I've outputted a new collection with the first two elements skipped from the start using the skip function. If I wanted to skip from the end instead, I could use skip last. We can also skip items based on a while condition. In this skip while example, we're essentially looping through the collection of numbers and skipping each item until this condition is false. Once it returns false, we then return all remaining items in the collection regardless. We can essentially do the reverse of skipping and instead take the first two elements of the collection using the take function, or take last to take from the end of the collection. And notice that the take while function takes all elements iteratively until this condition becomes false, which is the opposite of the skip while function. As we've seen previously, we can chain these functions together, for example skip the first two items and then take two. To group items into chunks, we can call the chunk function on the collection and specify the size of the chunk. In this example, we're splitting the numbers into chunks of 3, and then I'm just looping through to output of the console. Notice that the last chunk only has one element, because the collection isn't divisible by 3. Let's finish off by covering math and set operations. Using our collection of numbers again, I can easily find the minimum and maximum values with the min and max functions respectively. And to check the minimum and maximum age of our people array, I can specify the age in the lambda function. Similarly, we can find the average number and average age like so. And we can also get the sum of all values here. We'll move on to the set operations now, and start with the distinct function, which returns the collection without any duplicates. In this example, I've got a string array, and as you can see, the word the is only returned once, even though it appears twice in the array. We can also specify a lambda function with distinct by, if we want to check for duplicates a different way. If I didn't want two words of the same length to be returned, I can provide the length of each item, and there we are. If you want to exclude certain values from an array, you can use the except function, passing it a list of items that you want to be removed from the result. As you might have guessed, there's an except by function as well, which comes in handy when we want to exclude people from the people array, but we only know the people's names. We can pass in the excluded list again, and specify the name field in the lambda function afterwards. If you're familiar with Venn diagrams, you'll have come across intersections, which is essentially the common elements between two arrays. In this example, I can use the intersects function to get the intersection between these two arrays. Another one is union, and that returns all items from both arrays, removing any duplicates like so. We can similarly use intersect by and union by if we want to provide a field name in each case. I've got a second collection of people here, and I want to merge the two collections, making sure there are no duplicate emails in the result. Notice that the email charlie@example.net appears twice, but the name is different, Charles and Charlie. So for the intersection, we can return this duplicate item by specifying all the emails in the intersect by function, followed by the email field in the key selector. This is a similar sort of syntax to the join function we saw earlier on in the video. As you can see in the console, the item that was duplicated has been returned. And if we use union by, we don't need the select function this time, and all entries are returned this time without any duplicates. If you're looking for an example app that uses LINQ functions, I've created a suite of desktop apps in C# that are all open source. I've also made a language learning site built with readability that's 100% free. Check them both out in the description down below. Be sure to leave a like if you enjoyed this video, and subscribe to keep up to date with the latest from Zool Coding. Thanks for watching, and I'll see you soon.